So we're given this equation to describe the dynamic pressure Q of a fluid moving with velocity v, and n is the constant density of the fluid. So an engineer uses the formula to find the dynamic pressure of a fluid with velocity v and the same fluid with velocity 1.5 times that, right? What is the ratio of the dynamic pressure of the faster liquid to the slower fluid? So let's just say in this case that, so we want to find the ratio of the Q's between something with a velocity v and a velocity 1.5 v. So Q of Q1, let's just say of the slower one, is just equal to this, right? It's 1/2 times n, which is just some constant, times v squared. It's some velocity v. Q2 is equal to 1/2 n, right? It's just a constant, but this one has 1.5 times the velocity. So how do you express that? Just put it in like this, right? It's 1.5 v. It doesn't matter what v is. Whatever v is up here, we just have 1.5 times that. Squared. Don't forget your squared. So now we just kind of want to put one over the other, right? So we want the ratio of the faster fluid to the slowest. So let's put Q2 over Q1, which would give us 1/2 n 1.5 v squared over Q1, right? 1/2 n v squared. So from here, 1/2 cancels out, n cancels out. This is equal to, so 1.5 v squared is equal to 2.25 v squared over v squared. Again, when you're squaring it, you square this thing and then you square the v, right? That's a v squared. Sorry for the sloppy 2. So if we do that, then the v's cancel out as well, right? So your answer is just 2.25. So the Q of the faster liquid is 2.25 times larger than the Q of the slower liquid.